Greetings to all. Welcome to this presentation entitled Evacuation Friendly Design. Here we'll be looking at ship architecture and ship design, with the main question to be answered being, how can we design a ship that's optimized from an evacuation point of view? Because this is our interest in SafePASS. My name is Émeric Lacroix, and simply put, I'm an engineer in the R&D department of Chantier de l'Atlantique, and I've been coordinating our efforts for the SafePASS project. So, how can we upgrade a cruise ships? Generally, all cruise ships have a fairly similar structure independently of the yard it's being built in. You usually have some public spaces above. These are the outside decks on top, where you have plenty of sun, or you have swimming pools. It's a very enjoyable area. Down below, you have some cabin decks, a lot of cabin decks. And down, if you go down again, you will find some public spaces. These public spaces are located around the embarkation stations. So that's all the lifeboats that you're used to seeing on the side of a cruise ship. And here you will find some restaurants, main theaters, and all sorts of entertainment for passengers. If you continue going down, you will find a lot of crew spaces, working areas for crew, storage areas, all the crew cabins, and technical spaces like machinery, fuel areas, and so on. So in terms of evacuation, mainly there are three areas that are of interest. You obviously have your embarkation areas, so your LSA, so to speak. LSAs are life-saving appliance. It's what we refer to as lifeboats and anything that can carry a passenger out of the ship. So you have your embarkation areas on a certain deck. Then you have your muster station. So obviously in a cruise ship evacuation, you have two main steps. Well, first you will assemble people to big areas. So the big public spaces we referred to before, restaurants and main theaters, mainly. So you assemble people in these areas, and then you send them out from the musters to the embarkation station. So the LSAs. Then you have your main circulation, which is the third point, which is important. So these are the staircases, people to go down to the assembly stations and main corridors. So these are the three main areas for us. And now let's try to see if we can change all of this. Just quickly looking at this picture and this design. Well, the first question is, can we do something with the LSAs, the embarkations? You can see it's quite dense in the embarkation deck, so pretty much the entire usable length of the embarkation deck is currently used with lifeboats. You can see after the ship, there's a small area. This is what we call the MES, so Marine Evacuation System, inflatable system for people to go out of a ship. So this is also an LSA. A big portion of a ship's length is used, and you can't use really anymore because fore and aft are areas where the ship generates undesired waves. So you want to try to avoid these areas. Plus, you have a propeller in the back of the ship, which is not a good idea, generally for LSAs. So, okay, longitudinally, we can't change the LSA positioning. Let's try to move them up or down. Well, it's complicated also because, well, down, if the ship has a heel angle, you will quickly reach for water because the ship is very wide. We have very high beams on certain ships. So if it heels, quickly reach for water. So you have to put them above a certain height And usually that height is pretty much the limit for embarkation, so you can't really put them in any higher. And well, you see where this is going. The main circulation area is very designed for the evacuation to happen well, so you won't change much. A cruise ship is quite optimized, and that's why all cruise ships have fairly similar evacuation structures. So what I'm trying to say here is that people that have been designing ships for the past decades have been doing it pretty much in the right way. And it's quite hard to upgrade the architecture if you don't add some new elements. So what changes here in SafePASS is that we have new technologies. It's basically, you change the context. So you have new elements that you can put into your design, new technologies that give new opportunities in your ship design. For example, we have two main systems in SafePASS that are really important to the ship architecture, which are the new LSA designs. So usually these LSAs are very compact, save at a lot of space. So you're not filled up on the entire length of the ship anymore. You can actually try to play around longitudinally. And they have quite a versatile positioning. You can actually put them higher or lower, even slightly lower. So you can consider to put them on multiple decks. You can, as they're a lot more detachable, let's say, you can even consider to have mobile LSAs that you can move around the ship. That's a concept we've been looking at in SafePASS. Quite far out, but it's very interesting. The other system in SafePASS is a crowd management system. You can see here below. This basically gives the crew a picture of the situation and an ability to control the flow of people. So you can decide to put ships to send passengers in certain areas of ship, depending on the initial situation, if you have certain blocked routes, etc. So you can avoid some unnecessary travels within the ship. So that's very interesting. Well, you can actually, we don't have the need anymore for certain circulation area, and we can focus on what's important. And you'll be able to see in the next slide, which is a first example of what we can do when we take into account these systems. Here is a concept that we call 5.2. It is an interesting concept because we went quite far with this one. So here we integrated the new LSAs. You can see the LSAs being represented as boxes in fancy stuff around it. So all the green boxes pretty much are LSAs, and we positioned them on 2 decks. We have 6 LSAs in total, 4 on deck 7, 2 on deck 6. This means that it's a lot more spread out around the ship. It's not all on one deck, all focused and concentrated. People usually have, in this way, a more direct access to their muster station, because people on deck 6 don't have to go upstairs anymore. They can just directly go to the LSA. This removes some of the evacuation time and travel distance. And you also have a direct and safe passage for muster, so you avoid having to go long ways in the embarkation deck when you potentially can have quite bad weather going outside. Usually when you evacuate, it's when things are going wrong. So that's a good example of things we can do. Now, another idea, which is also maybe more of a system, but it also has a huge impact on the ship architecture. This idea is to have LSAs on rails, because we have a much more free embarkation. We can actually try to move it around. So we've been looking at this. It definitely has an engineering challenge to it, but we've been diving into this and trying to have some ideas of how much it would cost and how much it will weigh, if it's actually feasible or not. This allows you to actually adapt the LSA distribution to the passenger distribution. So for example, if you have a certain problem and you have to gather people more aft in the ship, for example, you have a fire in the front section of the ship in the main theater. So the concentration of people will be more aft in the ship, can actually move the LSA to that location. Also allows you to avoid some compromised areas. So if you have fire, you can actually move the LSA away from fire instead of having it burn with a fire. This sort of gives you a certain redundancy. Also, we do have some operational benefits. So meaning that in peacetime, it's actually interesting for a cruise ship. That's not the goal here in SafePASS, but it is something we usually tend to look at. So in peacetime, you can decide to store the LSA in a certain space, a certain area in the ship, and it leaves you a clear, unobstructed embarkation deck where every passenger can enjoy the cruise. So these I just shown two concepts, two ideas, two architectures. All of this being made possible by the SafePASS development. So obviously it is R&D, so we're not there yet, but we are trying to go there. Now I'll just show you a side note. This is kind of another subject, also very related to ship architecture, but in SafePASS, we tried to look at the ship and the LSA as a whole. So usually you validate the ship on one side, you validate the LSA on the other side, and then you say that the ship with the LSA is always validated. Where in reality, you actually have an interaction between the two. And the ship behavior, motion, and seas in sea can impact the ability to deploy safely an LSA and have people embarking on them in all safety. So we decided to do a whole bunch of testing. I'll show you two videos of the testing we did, where we had actually, I'll explain the setup. So you have a barge that's floating around. So it was all done in the marine facility in the Netherlands. You have this barge which represents the ship. It's a 5-ton barge, so it's quite a heavy model. And here you have the model of a lifeboat. So this represents the lifeboat, and we are going to execute drop. Waves are coming from the side. We're in beam C condition. And you will be able to see how this happens. So the lifeboat is going to drop, and we will see how this behaves. Okay, so a fair impact when you reach water, but all in all, this happens quite well. So we did hundreds of launches in different sea states, different orientation with between the ship and the lifeboat, to try to understand how things work during evacuation and what's the limit in terms of sea state. I'll show you another example. This is an example of an MES, which is an inflatable structure. Represented here, it's actually a foam material, reproducing the behavior of the inflatable structure with a certain Bosing system. And this is in heavy seas. Keep in mind, this is all model scale, so it is very, you would need to scale it up. Things happen much slower in real life. So you can see heavy waves, and we can actually study the impact of wave reflections. And we did this for, again, for a few sea state. Also studied if the ship has damage, if it heals, what are the influences. This is from a barge, which is quite static. Sometimes we had barge which was a lot more mobile, reproducing more ship motion. So this gives us quite a good understanding of how the ship and VLSA interact with each other, and how we can actually use VLSA around in the ship. Really, what are the limits to what we can do with VLSA? So this is all that I had to say for this presentation, and plenty more going on in SafePASS. I'm sure there will be opportunities to talk about this later. I hope you enjoyed this presentation. If you have any questions, please feel free to contact me. And thank you all for your attention, and stay safe.